Hi viewers, welcome to our MSD School of Computing channel, and once again thank you for being part of our MSD School of Computing YouTube channel. Viewers, before we enter into the topic IoT Basics Part-2 video, those are not subscribed till now, you are requested to subscribe my channel. Okay, now we start the session IoT Part-2 video. In this video, I am going to cover IoT definition, physical design of IoT, and then logical design of IoT. Viewers, you know IoT World Forum is there. It consists of many industries, especially those are involving cutting edge technology development. They define the IoT in their point of view. So in the upcoming slide, I am going to cover that information, and also the next topic, physical design of IoT, logical design of IoT. Nowadays, we discuss about smart cities, smart buildings, smart agriculture, then smart healthcare, like that. Everywhere we can discuss about connecting technology. It means that IoT technology. So as a technology developer, we must know the physical and logical design of IoT before developing smart product. That information also I am going to cover in this video. Here I mentioned a IoT definition according to European Union. A global network infrastructure linking physical and virtual objects through the exploitation of data capture and communication capabilities. It means that IoT refers to the network of physical objects that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices or systems through the internet. The next IoT definition according to International Telecommunication Union, ITU, a global infrastructure for the information society enabling advanced services by interconnecting physical and virtual things based on existing and evolving interoperable information and communication technologies. The third definition, IoT definition according to IETF, Internet Engineering Task Force. IoT is a worldwide network of interconnected objects uniquely addressable based on standard communication protocol. Then next, according to IEEE, Institute of Electrical and Electronics Engineers, the definition of IoT is a network of items each embedded with sensors which are connected to the internet. Then according to Wikipedia, IoT definition is the network of physical devices, vehicles, home appliances, and other items embedded with electronics, softwares, sensors, actuators, and connectivity, which enables these things to connect and exchange data, then creating opportunities for more direct integration of physical world into computer-based system, the resulting in efficiency improvement, economic benefits, and reduced human intervention. These are all the definition about IoT. In this slide I am going to cover a logical design of IoT. The logical design of IoT system involves planning and structuring the various components, data flows, interactions, and functionalities that make up the system, that make up the IoT smart system. Here I mentioned 12 important key elements and consideration for the logical design of IoT system. The first element, identify use cases and requirements. As a technology developer, here we need to define the specific use cases and the objectives of our IoT system. Then we need to identify what type of devices will be involved in our system, and then what data needs to be collected from the environment. Finally, as a developer, we must know what action needs to be taken based on that collected data. Then point number 2, device connectivity and communication. Here we need to determine how devices will connect to the network, and also we need to determine how it communicate with each other. For the communication purpose in IoT technology, lot of protocol is there. So as a technology developer, based on some factors, we can choose our communication protocol. For example, MQTT protocol is there, COAP protocol is there, HTTP protocol is there. Sometimes based on that product or based on that scenario, we can develop, as a developer, we can develop our own protocol, communication protocol. That protocol is always called as a custom protocol. So based on some factors like device capability, network conditions and data requirements, so based on these type of factors, we can choose our proper communication protocol for our communication, device communication. Then point number 3, data collection and sensor. Here we need to specify the types of sensor and data sources that will be used to collect information from the physical environment. Then point number 4, data processing and analytics. Here we need to plan how the collected data will be processed, aggregated and analyzed. As a developer, here we need to decide whether the data processing will occur at the edge node or in the cloud. So we need to decide as a developer. Then point number 5, data storage. Here we need to determine how and where the data will be stored. Then point number 6, security and privacy. So in this point we need to incorporate security measures to protect data and devices from the unauthorized access and then tampering and cyber threats with the help of some encryption algorithm, authentication mechanism, access control mechanism and then secure communication practices. We can secure our devices as well as our data from the third party. Then point number 7, user interfaces and interaction. Here we need to design an interface for users to interact with our IoT system. This may include web application or mobile application or dashboard and sometimes visualization tools to monitor device status. Then point number 8, integration with external system. Here we need to determine how the IoT system will integrate with other existing system as well as other existing application or services. This may involve APIs or webhooks or custom integration solutions. Then point number 9, scalability and flexibility. As a developer, here we need to design our IoT system with scalable in mind. Here we need to consider how the system will handle a growing number of devices and data streams. As well as we need to plan for flexibility to accommodate future update or future changes and new device types may be added in our current system. Then point number 10, event handling and automation. Here we need to define how events and triggers will be managed within the system. So we need to specify, as a developer, we need to specify rules and logic for automating action based on specific condition. Then point number 11, network topology and architecture. So here we need to decide the network topology as well as architecture, including the arrangement of devices, gateways and communication pathways. So we need to consider some factors like coverage area, latency and reliability. Based on that, we can decide or choose our network topology or architecture. Then point number 12, testing and validation. So here we need to plan for testing and validating the system functionality as well as performance of the system and security level of the system with the help of testing procedure to identify and address potential issues of our system before deployment. That is very important. Viewers, you just remember that the logical design of IoT system lays the foundation for its successful implementation. So it should be well documented and understood by the development team as well as stakeholders and then anyone involved in this project. So then additionally the design should be flexible, then enough to accommodate the changes, future changes and advancement in technology as the IoT landscape continue to evolve. So these are all the points under logical design of IoT system. The next slide I mentioned the physical design of IoT system. The physical design of IoT system, it always encompasses the selection of hardware components, placement of devices, connectivity solutions and the overall setup that enables the system to function effectively. So this slide I mentioned some of the key elements as well as consideration for physical design of IoT system. So here I mentioned 15 points under physical design of IoT. In the point number 1, device selection. So choose the appropriate devices and sensors based on our specific use cases and our requirements. Here we need to consider some factors like sensor accuracy, communication capabilities, power consumption and durability. Then point number 2, device placement. So here device placement under the point number 2, we need to determine the optimal correct location. Optimal means correct location. Optimal locations for deploying devices and sensor within the physical environment. Here also we need to consider some factors before launching our product. The factors like coverage area, sensor range, line of sight and potential abstractions. So these are all the factors we need to consider for device placement. Then point number 3, connectivity option. Select the appropriate connectivity solution for the devices. This may include Wi-Fi or cellular network or Bluetooth and then LoRaWAN, Zigbee or other some combination of these based on some factors like data range, then power efficiency, data rate, network availability. So based on these factors we can select appropriate connectivity solution. Then point number 4, gateway deployment. Here we need to decide whether to use gateways to aggregate the data from multiple devices before sending it to the central system. In sometimes gateway can improve efficiency by reducing the number of direct connections and managing data locally. Point number 5, power supply. Plan the power supply for IoT devices. Consider some factors like battery powered or solar powered or connected to wired power sources. So like that we can choose our power supply options. Then data transmission. Define how data will be transmitted from device to the central system. It means device client machine to server machine. So we can consider the frequency of the data transmission as well as message formats and any required data pre-processing. Then point number 7, enclosures and protections. Here we need to ensure, as a technology developer, we need to ensure that devices are housed in appropriate enclosures to protect them from the environmental factors like weather, dust, humidity and potential tampering. Then point number 8, data collection points. Data collection point. So we need to identify the specific point where the data will be collected and where it transmitted. This might involve installing sensor on specific equipment, then machinery, vehicles or locations. Then point number 9, network infrastructure. Here we need to evaluate the existing network infrastructure and make any necessary upgrades to accommodate the increased data traffic generated by the IoT devices. Then 10th point, communication reliability. So here we need to design the communication architecture to ensure reliable data transmission and then implement redundancy and failover mechanism to prevent disruption. Then location services is another important point. If relevant, we need to consider incorporating location services like GPS to track the real-time location of the devices. This can be useful for many applications, for example asset tracking, fleet management, then geolocation based services. Then point number 12, environmental factors. Take into account the environmental conditions of the deployment area. So as a developer, before launching we need to ensure that devices are designed to withstand temperature fluctuation, humidity, vibrations and other factors that could impact their performance. Then point number 13, scalability. Design the physical setup with the scalability in mind. So we need to consider how easily new devices can be added to the system and integrated into the existing infrastructure in future. And point number 14, maintenance and accessibility. Here we plan for the maintenance and accessibility of the device, smart device. So we need to ensure that devices can be easily reached for the troubleshooting or repairs or battery replacement if applicable. Then last point, regulatory compliance. Here we need to adhere to relevant regulations and standards that govern IoT deployment, especially in industries with strict compliance requirements such as healthcare and industrial sector. So these are all the important points, important key elements under physical design of IoT system. So the physical design of IoT system is closely tied to logical design, but here we need to ensure that the hardware components and physical structure align with intended functionality and goals of our system. So it is essential to thoroughly plan and execute the physical design to create reliable, then efficient and effective IoT solutions. So these are all the points under physical design of IoT system. So these are all the points in IoT Basics Part 2 video. So once again I request all the subscribers to subscribe my channel. The next video, IoT Basics Part 3 video, I am going to cover the topic like evaluation of IoT, then machine to machine communication, M2M communication, then what is IoT World Forum, what are all the roles they have. These are all the information I am going to cover the next part 3 video. Viewers, continuously follow my channel. Thank you for your patience listening. Thank you.